Welcome to Star 311, Study Section 1, Definitions and Rules of Probability. Introduction. Since participation in games and gambling is as old as mankind, it then suggests to us that the ideal of probability is almost as old. But the realization that one could predict an outcome to a certain degree of accuracy could not be done until the 16th and 17th centuries. This idea that one could determine the chance of a future event was prompted from the necessity to achieve a predictable balance between risks taken and the potential for gain. In order to make a profit, underwriters were in need of dependable guidelines by which a profit could be expected, while the gambler was interested in predicting the possibility of gain. In this study session, your focus will be directed to the definitions and rules of probability. Learning outcomes for study section 1. At the end of this study session, you should be able to discuss the basics of probability theory, stating the types and their definitions, state the relevant theorems and definitions that are central to the theory of probability. Probability. The theory of probability in its early stages was closely linked to the games of chance. Dice are commonly associated with games of chance. For instance, in a dice game, one is interested in only the numbers that rise to the top. If a single fair die is rolled, there are 6 outcomes and each of them is equally likely. If the probability of a number greater than 4 is required from a single fair die, then the denominator D is equal to 6. Since there are n is equal to 2 salient outcomes, namely 5 and 6, then the probability we want is 2 over 6, which is equal to 1 over 3. Probability can be defined as a measure of uncertainty. It can also be defined as a real value that measures the degree of belief that we have in the occurrence of an event. The following definitions of probability based on different approaches to the concept are classical or a priori probability, frequency or a posteriori probability, axiomatic or theoretical probability. 1. Classical or a priori probability. If there are n number of exhaustive, mutually exclusive and equally likely cases of an event, and suppose that NA of them are favorable to the happenings of an event A under the given set of conditions, then A is equal to NA over N. An example is the toss of a die once. The 6 possible outcomes are 1, 2, 3, 4, 5, 6. The probability of occurrence of a 2 is 1 over 6. The probability is a priori, that is, it can be determined before carrying out the experiment. Note, the word exhaustive assures the happening of an event, either for or against, and disallows the possibility of happening of neither for nor against in any trial. 2. Frequency or a posteriori probability. This probability can only be determined after the experiment has been performed. The experiment is repeated many times under similar conditions and observations are taken. The probability P is then approximated by the relative frequency to which the repeated observations satisfy the event, that is, lim n approaches infinity, n of A over n. 3. Axiomatic or theoretical probability. This is based on available information. The probability of an event A in relation to an experiment with sample space S is a real valued fraction PA which satisfies the following axioms. P of A is greater than or equal to 0. P of S is equal to 1. 0 is less than or equal to P of A less than or equal to 1. If A1, A2, A3 are elementary events in a sample space S, then the probability of the union P into bracket union I is equal to 1, infinity AI into bracket is equal to summation I is equal to 1, infinity P of AI. Example 1. Consider S is equal to head, 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 tail, tail, head, tail, tail in bracket. Then P of U for I is equal to 1, AI in bracket is equal to P of head, head plus P of HT plus P of HT plus P of TT is equal to 1 over 4 plus 1 over 4 plus 1 over 4 plus 1 over 4 is equal to 1. Probability axioms. The function P such that f approaches 0, 1 in bracket is a probability function if the following axioms are satisfied. P of A is greater than or equal to 0, P of S is equal to 1. P of A1 union A2 union in bracket is equal to P of A1 plus P of A2 plus. Definitions of terms. The following are the definition of some of the relevant terms in probability. 1. Sample space S. This is the totality of possible outcomes of a random experiment. For instance, in the experiment of tossing a coin, S is equal to HT in bracket. 2. Equiprobable sample space. This is the sample space to which we assign each of the sample elements equal probability. The sample elements are said to be equally likely or equiprobable. 3. Event. This is a subset of a sample space. Suppose S is equal to HH, HT, TH, TT. The event E of 2 hairs occurring in the toss of a coin twice is E equal to HH. 4. Sure certain event. The sample space S is the only sure event. The probability of a certain event E is 1. P into bracket E is equal to 1. 5. Mutually exclusive events. 2 or more events are said to be mutually exclusive if the happening or occurrence of any one of them excludes the happening of the others. 6. Union of n events. The union of events A1, A2, A3 to AN is denoted by A1 union A2 union A3 union.AN. 7. Intersection. Product of 2 events. Consider 2 events A and B. The intersection between the 2 events is usually denoted by A intersection B or AB. For n events, we have A1 intersection A2 intersection A3 intersection AN. 8. Dependent and independent events. 2 or more events are said to be dependent or independent according as the occurrence of one does or does not affect the occurrence of the other or others. 9. Compound events. Joint occurrence. This is the simultaneous occurrence of 2 or more events. 10. Impossible event. This is the complement of the sure event. It is an empty set. Rules of probability. The following are the rules of probability. Theorem 1. Let S be a sample space and function P be a probability function on X, and P in bracket dot be a probability function on S. Then the probability, I take it again. Theorem 1. Let S be a sample space and P dot in bracket be a probability function on S. Then the probability that the event A does not happen is 1 minus P of A. That is, P A prime is equal to 1 minus P probability of A. proof, follow the steps below. Theorem 2. Let S be a sample space with probability function, then 0 is less than or equal to P of A less than or equal to 1 for any event A in S. Check the proving below. Theorem 3. Let S be a sample space with a probability function. If far is the impossible event, then P of far is equal to 0. Also study the proving below. Check Theorem 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and Theorem 15. Multiplicative law of probability. If there are two events A and B, probabilities of their happening being P of A and P of B respectively, then the probability PAB of the simultaneous occurrence of the events A and B is equal to the probability of A multiplied by the conditional probability of B. That is, the probability of B when A has occurred, or the probability of B multiplied by the conditional probability of A. That is, P of AB is equal to P of A, P of B over A is equal to P of B, P of A over B. Summary of Study Section 1. In this study session, you have learned about 1. The different approaches to the concept of probability. 2. The definition of some of the relevant terms in probability. This is the end of Study Section 1. Thanks for listening.